So this is a drill press. Its main purpose is to drill holes into our workpiece. It's composed of mainly three things. We have our table, our spindle, and the belt case on top of the machine. Whenever you're using a drill press, there's always three main things you need to focus on. There's how you're going to hold your workpiece, how you're going to hold your tool, and at what speed you're going to be removing the material in said workpiece. So I'd like to begin with the work holding. The work holding on the drill press is mainly all going to be done on the table here. The table on the drill press can be adjusted in height as well as rotate around the back column of the drill press. All that can be done by simply unlocking the handle on the left-hand side of the column over here. Once you have the table unlocked, you can then adjust the height by turning the crank on the right-hand side of the column, like so. And you can also notice that the table is free to move and pivot around the back column. Once you have the table set to your required height and position around the column, it's very important to always lock that handle on the left-hand side of the column. That way, your table is very stable and rigid, and it's not going to move while you're trying to machine your workpiece. So when it comes to fixturing your workpiece, there are many ways that you can do so. The easiest and fastest way is probably to use one of these vice grip clamps. These clamps are fixed to the table in one of these slots along the surface and can be clamped down onto your workpiece simply by pushing down on the handle on the back. And we can adjust the tightness of the vice grip clamp simply by adjusting the back thumb screw on the clamp. If I tighten the thumb screw, I will tighten the grip on the clamp, and if I loosen the thumb screw, the reverse will happen. Whenever you're drilling onto the table, you want to avoid drilling directly into the table. To do so, we always want to use a piece of wood underneath our workpiece, and that way it kind of catches the drill bit as we're drilling into it and avoids us damaging the table itself. You can usually find a scrap piece of wood laying around the shop. There's generally some really near the drill press, and you're going to place that onto your table. Once you have your piece of wood and the clamp in place, you can then take your material, your stock material that you want to machine, place it along our block of wood, and try and clamp it down into place. Now, as you can see, my clamp is not doing anything, so I'm going to tighten the thumb screw on the back of it until my workpiece is held nice and securely against the table. You want your piece to be properly secured, and so much so that you can't rotate or move the workpiece on the table. If you can move it, then the chances are that the drill press is going to be strong enough to rip it out of its clamp and start throwing it about. So the next thing we need to focus on when working with a drill press is how we're going to hold on to our tools. The tools are going to be held in the middle section of the drill press in the spindle. Inside the spindle we have the Jacob's chuck here. The Jacob's chuck has 3 jaws that are going to clamp down onto our tool, and they open or close by turning the outside column of the drill chuck. Now, the main tools we're going to be using on the drill press are going to be drill bits. There are 2 main areas of the drill bit that you need to know about. There's the shanked portion on the back side of the drill bit, which is the area that we want to hold on to with our Jacob's chuck, as well as the fluted portion. So the fluted portion is what's going to be doing the work and cutting into our material, as well as evacuating the chips from the end. The important reason why we need to remember the shanked portion is because that's the only place on the drill bit that we want our Jacob's chuck to be holding on to. The reason being, the shanked portion is nice and solid on the back and allows for a proper clamping area to hold on to. If we were to hold on to the fluted section, we would find that the Jacob's chuck wouldn't do a good job at holding on to our drill bit, and the drill bit will end up turning inside the Jacob's chuck, damaging the drill bit and also damaging the chuck. So we want to avoid that by always holding on to the shanked portion of the drill bit. When we're sliding our drill bit into the drill chuck, we always want to make sure that the 3 jaws are open wide enough for our drill bit to be inserted inside. So we're going to insert our drill bit inside the drill chuck. The height at which we insert our drill bit is very important because, like I said, we don't want our fluted portion to be stuck inside. So we're going to position our drill bit so that the fluted section is right outside the 3 jaws. And it's also very important that we're held within the center of the spindle. This is a common mistake that people will make, is they'll hold their drill bit off center, so the drill bit is now only being held by 2 jaws. And at first glance, it doesn't seem like it's out of place. However, when the drill bit starts spinning, it's very easily noticeable that the drill bit is spinning eccentrically along the center axis and is not going to be drilling any holes for you anytime soon. So take a second, bend over, and make sure that you're, in fact, in the center of the 3 jaws and spinning concentrically with your spindle axis. Once the drill bit is inside the drill chuck, it's also very important to use what's called a chuck key in order to properly tighten the drill chuck so that it holds onto that drill bit nice and tight. So now that we have our workpiece fixtured on the table and our tool fixtured inside the spindle, the last step for us to do is to think about at which speed we're going to be machining our workpiece. The removal rate of material when machining is extremely important regardless of what type of equipment you're using inside the workshop. Whether you're going too slow or too fast, the results can be disastrous and as well dangerous towards you if you're not going to the proper speed. So in order to find the speed that we need to use for a certain operation, we refer to this equation that takes into account the diameter of our tool as well as the material that we're going to be machining. That equation is 4 times the tool diameter divided by the speed coefficient of the material. The speed coefficient of the material will change drastically depending on the hardness of the material. So if we're cutting into softer materials such as plastics, the SFM values that we'll find will be much higher than if we're drilling into harder materials such as steel. The tool diameter is important because the bigger the tool diameter, the more material we're going to be removing with each rotation of the tool. So taking these 2 factors into account, we can then plug them into this equation and it'll output a speed that we need to use for this certain operation. So now that we've calculated our speed using the equation, we now have to change the drill press so that it outputs that speed at the spindle end. In order to do so, we are going to change the belts inside the head case. However, before opening the head case and sticking our hands in, we always want to make sure that the power is completely turned off to the machine, it's unplugged from the wall, and it's safe to access the internal components. So now that I'm sure that the power is turned off and I'm safe from harm, I can now go ahead and open up the head case in order to have a better look at what's going on inside. We're going to look at the belt configuration sticker on the back of the head case. This is going to show us the different configurations that are possible along these 3 pulleys and their outputted speed. Now the 3 pulleys that we have the one in the front, which is the driven pulley, the middle pulley, the idler pulley, and the back pulley, which is the driver pulley. The 3 are connected by the 2 belts along each side. So depending on which configuration that the belts are in, will determine the speed that's outputted to the spindle. Each of these pulleys has different notches, which corresponds to different levels. On the front half of the belt case, we're going to name them alphabetically, and on the rear half of the belt case, we're going to name them, we're going to number them from 1 to 4. So right now, this drill press is in configuration D3. Now, if I want to change the speed inside this drill press, I'm going to need to therefore change the configuration of the belts. And first, I'm going to need to remove the tension on the system. So in order to do so, I'm going to loosen these 2 thumb screws on either side of the machine. There's one on the right-hand side here, and there's one on the left-hand side over there. Once I've loosened those 2 thumb screws, I can then pull on this chrome lever here and pull the motor forward, which will then loosen the tension on the belts. See, now they're nice and loose. To remove them, I shouldn't have to fight with anything. If you're fighting with the system, then you're likely doing something wrong. All you have to do is push up on the belt a little bit, and then turn the system until it moves up a level. Push up again, move, and then the belt should come right off. So I'm going to do the same thing on the front pulley. Push up a little bit, turn, and it should come right off. Once both belts are removed, then I need to look at the sticker and look at which configuration I need to use in order to get the new speed. So if I'm going to change this drill press into configuration A2, 2 being after A, I'm going to need to put the back belt on first. So I'm going to take my number 2, my rear belt, and position it into the number 2 groove of the middle idler pulley. Then I'm going to pull the pulley backwards and reach for the back pulley. Once that's done, the belt is on level 2 of both pulleys. Then I can pull the pulley forward to increase the tension on the back belt, as well as prepare it for positioning for the first belt. So I'm going to take the first belt and position it in the middle pulley. I always want to work from the middle pulley outwards. This is going to make a big difference in the ease of putting the pulleys on. So now I'm going to be putting the front belt on. I always want to work from the middle pulley outwards. This is going to drastically improve the ease at which you put the belts on in their proper grooves. Otherwise, you're going to be fighting the conical geometry of the pulleys, and it won't end up working the way you want it to. So I move from the middle pulley outwards, and I pull the system forwards. All I want to do is line up the first notch here on the first pulley, and then turn the pulley until everything slides into place. Now that both belts are in their proper configurations, I can then apply tension on the chrome lever. While I'm holding the tension on this chrome lever, I can then tighten the thumb screw on the left-hand side of the machine, as well as the thumb screw on the right-hand side of the machine. Once I've verified that the belts are indeed in proper tension, I can then close the head case and get started with my drilling operation. So when it comes to the actual drilling part of using a drill press, just quick reminder, we need to clamp down our workpiece, make sure our tool is nice and fixed inside the drill chuck. I've also adjusted the speed so that it's within the proper range. So as you can see, my piece is still kind of moving around. So what I want to do is clamp it down a little tighter until it's not going to move anywhere. We have our piece of wood underneath, ready to catch the drill bit. I'm now ready to turn on the machine and begin my drilling process. Now, depending on the material, you're going to go about this in different ways. For soft materials, I don't need to worry too much because the material is soft enough that whatever drill bit I use, I'll be able to pierce no problem, and I won't need to worry about drill bit deflection, walking around, things like that. But for harder materials, the force required, or the down pressure on this drill bit as it's trying to pierce the material, is going to be strong enough that the drill bit is going to want to do one of two things. It's going to want to wander across the surface, so it's not going to want to drill straight. It's going to want to deflect, and it's going to want to bend. And if the drill bit starts bending, there's a good chance that the drill bit's going to break, and that can be very harmful. So we're going to have to start off with smaller drill bits, and then work our way up to the final size, depending on what the final diameter of the hole you want to drill is. And in fact, even if you're working with really hard materials such as steel, you're going to want to use what's called a center drill. So the center drill has a nice, small, fine point here, and it's very short and rigid. It's very stocky in the center. And this is going to permit the drill to be very rigid and not deflect or not wander across the surface. So it's going to drill a nice straight hole. Once we make a nice starter hole or a pilot hole into the surface of our workpiece, then we can follow up with maybe our next size drill bit, and then finally work our way up to the half-inch drill bit if that's what we're getting our way to. But like I said, for plastic, we can go straight forward with, I have had great success with anything smaller than 3/8. Once I get bigger than 3/8 of an inch, then I start stepping up. However, anything smaller than that, I usually just plow right through and it works just fine. So when it comes to drilling, you're going to use one hand to lower down the drill bit. And you always want to keep one hand free and clear to hit the emergency stop on the front face of the drill piece. And the main danger when drilling is that your piece gets ripped out from the clamp, pulls up off the table, and starts spinning. If that's the case, all you want to do is turn the machine off. If anything bad happens, you always turn the machine off and you wait for it to stop spinning. You never want to stick your hand in front of it and try and grab your workpiece. The machine is much stronger than you are, and you're likely going to get really hurt. So remember, if anything goes wrong, just turn off the machine and wait for things to slow down. So I'm going to turn on the machine and I'm going to start drilling into my workpiece. I never want to impact the drill. I never want to go down in quick succession and hammer onto the workpiece. You want to ease the pressure in. So as I turn the machine on and I lower the drill bit, I'm going to make contact with the surface and then lower my drill bit until it starts piercing. Lower again, pierce some more. So this is what's called pecking motion. So I'm going to want, and I don't want to do one continuous motion all the way through my workpiece. I want to allow the drill bit to cool down, evacuate these chips from the hole so that it's not getting all buried in and of itself. So I want to lower, touch the surface, pierce a little bit, come back out, lower, touch the surface, pierce some more. Okay, and I'm going to do that until I reach the bottom end of my piece of plastic. So touch the surface, pierce, raise, evacuate the chips, lower, pierce, raise, and I do that until I've cleared my workpiece. And you're going to feel a significant change in resistance. Once you pierce the material completely, you won't feel any of the chips being formed, you won't feel the machine working to drill the material, and then you can safely evacuate, turn off the machine, and take out all the chips. Just a quick note with plastics, it's usually a lot easier to start your hole, you have no problem drilling, but once you get to the bottom end of your workpiece, so on the other side here, oftentimes it'll want to grab, because once the middle of the drill bit pierces, the extremities or the circumference of the drill bit hasn't pierced yet, and it really wants to grab that outside and rip it free and pull it out of the drill press. So with plastics, you may be more lenient, you're like, it's just plastic, it'll be fine. Really make sure you clamp down your plastic workpiece, because oftentimes these are the hidden dangerous ones, and they'll get ripped free and start spinning around. With steel, we don't see that as much because the chips form much more cleanly, and the material itself is rigid enough that it's not going to come out of its vise as much. But yeah, if you're drilling into hard materials, always remember to use the center drill first. I can't stress that enough, because if you don't use the center drill before starting your hole, you'll find that your drill bit is going to wander, you're going to drill crooked holes, and you're going to break the drill bits very often. The important thing is to take your time and do it right. If you try and speed through the drilling process, that's when things are going to start going wrong. So I figured I'd demonstrate drilling into metal. Now I'm going to try and drill the same diameter hole that I drilled in the previous plastic piece in this new aluminum piece that I have laying around. Seeing as it's metal, I can't directly start off with the 1/4 inch drill bit like I did on the previous piece. I have to start off with the center drill. The center drill is going to be used to prevent, like I said before, the drill bit from deflecting, breaking, and wandering across the surface. So since I've switched material and I've also switched the diameter of the drill bit, I did need to move the table, adjust it. I needed to clamp my workpiece with a new thickness, so I had to modify the clamp. And I did recalculate the speed, and I needed to adjust the drill press to output the proper speed. So I've already done all that. Now I just want to show the difference in drilling different materials, such as metal, and mainly how to use the center drill. Because the center drill is one of those tools where you'll never drill completely through a material. You really want to use it to start off a pilot hole and nothing else. So I just want to demonstrate what that looks like. So I'm going to turn on the drill press, and I'm going to lower down again until I make contact with the surface. And then I'm going to slowly increase the pressure until I start piercing into my material. And the trick is to go low enough until the tapered section of the center drill starts appearing onto the surface. So right about there. So I'll show you what I mean by the tapered section. If we look closely at the center drill, so we have the tip of the center drill over here, and then it starts tapering off into this bigger diameter over here. So what we want to do is we want to pierce and we get through all this little section, and then once we start climbing this tapered section, that's where we're going to let off, and we can move on to the next drill bit size. So now that I have my pilot hole here, I'm going to now switch out to the 1/4 inch drill bit, and then I can follow through and drill this one. So I went and switched out my drill bit, calculated the new speed, switched the speed, reclamped my workpiece, aligned it properly, and now I'm ready to drill the final size of 1/4 inch into my aluminum workpiece. From this point on, it becomes very, very similar to the demonstration in the plastic workpiece. The only difference is that I needed to have that center drill dimple in my surface. So I'm going to turn the machine on. I'm going to lower my drill bit so it's aligned with the hole, touch the surface, then I'm going to lower, raise, touch the surface, lower, raise, touch the surface, lower, raise, touch the surface, lower, raise, and I've gone all the way through. So a very similar process. You may have noticed that it was a little more chattery, a little bit louder. That just comes from drilling in harder materials. And the center drill starts a different taper than the same taper on the drill bit. So at the beginning, it's always going to be a little rough going in. But once the drill bit settles and digs its own hole, then things are usually smooth sailing from there. That concludes the drill press tutorial. Just remember to always focus on your work holding, your tool holding, and the speed at which you're going to be removing that material. If you have all those thought out and well done, then drilling isn't that hard of a machining process to get on your workpiece.